In this problem, you're given a differential equation, which is just an equation that has a derivative, and they tell you f of x is the solution, and that y equals negative 2 is tangent to the graph of f. Okay? Find the x-corner of tangency and determine whether there's a local max, min, or etc. Okay. If y equals negative 2 is tangent to the graph of the function, that implies that you have a horizontal tangent because y equals negative 2 is a horizontal line. They're telling you there's a horizontal line that's tangent to the graph, so they're really telling you that you have a horizontal tangent in this graph. So what does it mean if you have a horizontal tangent? It means that the slope is 0. So right away you should be thinking this. The only way dy dx can be 0 is if the top is 0, so 3 minus x, so x is equal to 3. There's my first point. Then they want you to figure out whether f has a local max, min, or neither. Now, we cannot do a number line here because your f prime has x's and y's, so I can't test points because I can't find a corresponding x and a y value. So this is where you're going to do your second derivative test again. So I'm going to use the quotient rule and find my second derivative. The derivative of the top is negative 1 times the bottom minus the derivative of the bottom is y prime times the top all over denominator squared. Okay? Now, your x value is 3, your y value is negative 2, that's the corresponding y value. Your y prime is, what do you get when you plug in that point? And we just set up from above, the reason x is equal to 3 is that dy dx is equal to 0. So there's your x, there's your y prime you're going to plug in 0, and if you do that you should get 1/2, which I know is a positive value. So we know that that means that the original function is concave up. So if it's concave up and you have a horizontal tangent, I know that is local min by the second derivative test. So because second derivative was positive and the first derivative is equal to 0, which we already showed. Part B, find y equals g of x. So y is equal to g of x. They want you to solve this differential equation. So let's go ahead and start with my differential equation. Step 1 has to be separate your variables. So I'm going to move the y over here, move the dx over here. Take the integrate both sides, antiderivatives, y squared over 2, 3x minus x squared over 2 plus z. Okay, I'm going to go ahead and solve for y first. So I'm going to multiply everything through by 2. It's up to you. You don't have to do it this way. Again, 2 times a constant is a constant, so I'm going to leave it as is. I'm going to go ahead and solve for y at this point. Okay, the point that they give us is that g of 6 is equal to negative 4. Okay, now if you want, so if I plug in negative 4 for x, negative 4 for y, plug in the 6 here, I believe you should get 16 for c. So if I solve for y, make sure that plus c should be underneath the square root. You cannot take that plus 16 out of the square root. And the other thing is, when you take the square root, you have a plus or a negative, but this value is a negative value, so you need this to be the negative square root function. So this is your solution.